Hi, everyone. This is Mr. Thomas from the Legend team. We're going to be working with some algebra equations with variables on both sides. And instead of just jumping straight into the rules, we're going to look at it in terms of pictures and real-life examples first. So in this worksheet, Geology Rocks equations, I'm going to go through some problems. I'm going to ask you to figure out what you think the answer is first, and then I'll show you some strategies that might help and how that's going to lead into steps and rules that we can use in the algebra equation that hopefully will make a little bit more sense. So, Mr. Anderson is a geologist and has a laboratory full of rocks. He knows each rock weighs exactly 1 pound, and he would like to figure out how many rocks are in each crate. To figure that out without opening the crates, Mr. Anderson places crates and rocks on a scale until they are balanced. Using his math skills, he is able to reason how many rocks are in each crate without having to look inside. So this following picture represents the first set of crates and rocks Mr. Anderson put on the balance. How many rocks are in each side of the crate? Now, for this one, we're not worrying about doing it with algebra right now. Just use logic and reasoning. And how many rocks are in each one of these crates? Keep in mind that however many rocks are in this one, it has to be the exact same number of rocks in this one, and the exact same number of rocks in this one, and the two sides have to be balanced or equal, so that they weigh exactly the same. So what do you think it is? All right, so you should have gotten x equals 2. The number of rocks in each crate is 2. There are 2 rocks here, 2 rocks here, and 2 rocks there. And there are a number of different ways to do it. You can just kind of look at it and figure it out possibly, or maybe you were simplifying this problem in order to get to a final solution where you have a variable on one side and a number on the other, because that's what our solutions will look like. So let's, instead of doing this problem, let's break it down and do a couple different problems at a time, focusing on 1 or 2 particular strategies. So in this one, take a second and look at problem number 2. Can you figure out how many rocks are in each crate? Okay, so let's see how you could have done this. When I'm looking at this one, I know I want variables on one side of my equation, and I want the number on the other. And so variables on one side, numbers on the other. If I have things, I want the variables to be over here, but I have these extra stuff. So I'm going to scratch out 2 rocks from this side. Basically, I took it off of the scale. But if I want the scale to stay balanced, I have to take 2 off of the other side as well. And then I look to see, I've just made the problem simpler. Now I know that 4 crates are going to equal 16 rocks. And then I can divide these rocks into 4 piles. And each one of those crates or each one of those piles would be x equals 4. So that's 4, 8, 12, 16. And we had 2 extras. That's 18. And 18 on the other side was the original value as well. So when we had numbers or rocks on both sides, we just removed the stuff from both sides to create a simpler problem. Here on problem number 3, we have another problem like that. But this time we have variables on both sides or crates on both sides. What are you going to do? Try to figure out how many rocks are in each crate. Okay, so you may have already been able to figure it out. Maybe you were just giving me a guess. But if you simplify the problem, if we try to find a way to make it simpler, since I have variables on both sides, and I know in my final answer, I want a variable on one side, and I want numbers on the other. So I'm going to get rid of whichever part of this equation I don't want. I have 2 crates that I can take away from this side, and 2 crates that I can take away from this side. As soon as I've taken away some of those variables from both sides, I'm left with 1x and 12 rocks. And that's my solution. A variable equals 12. By removing extra stuff, if we have things on both sides that we can get rid of, you can simplify the problem. Well, this problem we have both. We have variables and numbers on both sides. So take a second. How many rocks do you think are in each crate? So if this problem looks too complicated the way it is right now, you're going to simplify it. Find things that are on both sides. I have a crate here and a crate there. If I remove both of those, the scale is still balanced, my equation is still balanced, and then I can also take away 8 rocks off of this side, as long as I also take 8 rocks off of this side, and I'm left with 1 crate equals 4 rocks. X equals 4, or X equals 12, or X equals 4 again. You are just going to remove things from both sides until you can simplify your problem. Next. Last one. And again, each problem is getting a little bit more complicated. Use the strategy we were just doing. If you need to draw it out on a piece of paper next to you, go for that. Do that as well. Take a look at these and see if you can figure out how many rocks are in each crate. Well, if you used our strategy to remove things from both sides, you would have taken away 2 crates from each side. You would have taken away 3 rocks from each side. And you would have been left with 3 crates on this side and 21 rocks on that side, which means that every crate has 7 rocks. So we have been doing it so far by just looking at a scale that's balanced, taking stuff off both sides. We will do the exact same thing when it's a regular old algebra problem. We're going to divide our equation into 2 balanced sides, right through the equal sign. And then you're going to take away things from both sides. Both sides have variables. So if you take away 5x's from both sides, you are left with 6 and 2x. So if 2x is equal 6, then x equals 3. And the reason I took away the variables from this side is because this side had my variable and this side had my number. And I know that I want variables on one side, numbers on the other. In our next problem, this side has numbers. That means this side needs to have variables. And so we take away, all we want on this side is the variable, so we need to take away the number, and whatever we do to one side, we do to the other. 4x equals 24. And divide both sides by 4, and x equals 6. Remember, when you have a problem that's more complicated, always try to simplify the problem first by distributive property and then combining like terms. Take a second and try these last 2 problems and see how you do. So for problem number 8, you should have distributed first. Make sure you distribute to everything inside the parentheses. 2x equals 8, or 2x plus 8 equals 16. Divide your problem into 2 sides. Always get rid of the adding and subtracting first, and then get rid of the multiplying and dividing second. X equals 4. And again, on this problem, divide your problem into 2 sides. We have variables on both sides, and I only want variables on one side. And I want the numbers on the other. So if this side I want the variable, that means I need to get rid of the number from this side. This side I want the numbers, so that means I want to get rid of the variables on this side. By getting rid of these variables, and by getting rid of these numbers, I've created a much simpler problem. 2x is equal 6, so that means x equals 3. If you have variables on both sides, get rid of the variables from one of those sides. Eliminate one of those terms so that you can create the simple 2-step equations that we're used to. There is a Google form for you in your Google Classroom, so go ahead and check into that. go ahead and try those problems, see how you do, and we'll be working more on this in the next few days. Thanks.